Good morning. I wish I could be there with you all for this workshop today, but unfortunately, the putting things back together again after two back-to-back hurricanes in Sarasota, Florida, has made it not possible for me to spend the time traveling to Australia right now. So this is second best. Hopefully, it will work for you to some degree, and I'm always available to answer questions that might arise from the presentation I'm going to give today. And the presentation that I'm giving is authored by me and also by Aaron Barleycorn, my field manager with the Sarasota Dolphin Research Program, who's done many of the interventions, especially the remote interventions that I'll be describing today. So in terms of the organization of today's talk, I'm first going to describe to you how we find and evaluate entanglements in Sarasota, Florida. And this is through long-term study of a resident dolphin community. I'll also talk a bit about risk evaluation from data we've been able to compile over many years. We'll talk about disentanglement response options, including remote disentanglement of free-swimming dolphins, rescue treatment and immediate release on site, follow-up monitoring, and rescue, rehabilitation, and release of individuals as well. And I'll pull this together at the end in the conclusions by sharing our decision tree. But I'd be remiss if I didn't give a shout out to the folks that have made this presentation possible, and especially Mote Marine Laboratories Training Investigations Program, the staff and volunteers of the Sarasota Dolphin Research Program, and the National Marine Fisheries Service Marine Mammal Health and Stranding Response Program and its various field offices, when we've done this with support through various NOAA Prescott grants over the years. We're able to utilize regular systematic monitoring of resident bottlenose dolphin community in Sarasota Bay, Florida, and this facilitates timely detection of entanglements. Our work began in 1970 with the tagging and tracking of dolphins in the Sarasota Bay area, at a time where nothing was really known about the movement patterns of dolphins. Over the years, as we began to learn about residency of dolphins in the Sarasota area, we continued our research and took advantage of the fact that we could repeatedly find recognizable individuals with a lot of background information. Since 1989, this research program has been led by Brookfield Zoo Chicago, now previously known as the Chicago Zoological Society, and we've been based out of facilities at Mote Marine Laboratory in Sarasota. Monitoring occurs as part of a longitudinal study, the biology, behavior, health, and ecology of individual dolphins and their ecosystem. The work is performed by a highly trained and dedicated staff, some with the program for decades, and with a number of highly skilled collaborators from around the world. Our staff is shown in the box in the upper right-hand corner here. The way that we study these animals and obtain the information that allows us to be able to evaluate interventions is through a variety of techniques. And going clockwise, starting in the upper left, we use monthly photographic identification surveys to keep track of the distinctive individual dolphins in Sarasota Bay. And this allows us to build a catalog of resident individuals and then to amass through other techniques the background information that fills out our cast of characters. About 96% of the dolphins in Sarasota Bay are recognizable from nicks and notches on their fins. We use passive acoustic listening stations to keep track of the ecosystem and dolphins and their prey remotely. From time to time, we engage in tagging, whether it involves satellite link transmitters or digital archival acoustic tags. I'll talk more about tagging later on. We work closely with Mote Marine Laboratories Stranding Investigations Program to help recover carcasses and understand what brought about the demise of the individual dolphins. Moving now to the bottom, using this well-known cast of characters, we can perform focal animal behavioral observations in a standardized way and enhance these through acoustic recordings and drone observations to really get fine-scaled behavioral observations and recordings of these animals. We obtain samples from individuals in a variety of ways. One way is through biopsy dart sampling, a technique that's been used tens of thousands of times around the world to get a small sample of tissue. We recognized long ago that we needed to put the animals into an ecological perspective to really understand what they're doing. So we also engage in seasonal purse seining to look at availability of prey, and we do sampling and tagging of bull sharks as an indication of what the predator of these animals, primary predator, is doing and whether there's competition going on. And then finally, periodically, we engage in catch and release health assessments. This involves catching small groups of dolphins in shallow waters where we can work with them safely, performing a variety of veterinary examinations and samplings on the animals, and then releasing them right on site. And with this information, we've come up with a very well-known resident community of dolphins. The dolphins in Sarasota Bay have been found to live in a multi-decadal, multi-generational, year-round resident community of about 170 individuals. We've studied 6 generations over the decades, spanning up to 5 concurrent generations at any given time, with individuals up to 67 years of age. And we've seen an annual population growth rate of about 2.1%. The map on the left gives a sense of the stability of the home range of the community. This is for one individual, at one time the oldest individual in the community, and the different colors represent a different decade of FB54's life, showing her ranging through the entire community range from the southern edge of Tampa Bay down to Venice Inlet, but showing that she concentrates her sightings, her positions in the northern half of the community home range in her neighborhood or her core area. Looking to the right-hand map, we can look at stability in a different way by looking across generations within a lineage. These sightings, indicated by a different color for each generation, show the utilization of one maternal lineage over many decades, again, using the entire range of the community from southern Tampa Bay down to Venice Inlet, but with each individual having some particular portion of the range that they utilize as their core area or their neighborhood. Working with Mote Marine Laboratory's Training Investigations Program, we're able to identify cause of death for many of the dolphins in Sarasota and provide a cradle-to-grave study situation for the dolphins. What the stranding program has found is that about 25% of the deaths that can be identified are from human interactions. And this is based on the fact that we can find about 1/3 of the dolphins that disappear in the area and recover the carcasses for them. Of these known cases of cause of death, 20% are from fishing gear, and this leads us to the further discussion of entanglement today. We engage in education and outreach to try to preclude the need for interventions, but the need for rescues continues. As one encouraging indication, during 2006 to 2019, we had 8 local interventions, or about 0.57 per year, but in the most recent 5-year period, we've only had 2, or about 0.4 per year. We'd like to think that that's at least in part a result of our increased educational and outreach efforts, but we can't say this for certain. The fact of the matter is, though, that there is a continued need for interventions in the area. Given the long-term nature of our research in Sarasota and working with colleagues in other places, it's allowed us to be able to evaluate the risks and benefits of interventions and document these in a variety of publications that are shown here. And also they're available on our website at sarasotadolphin.org if you want to take a closer look at them. So what have we found? Well, from a paper in 2008 that we published on injuries, we found that of 49 cases of gear entanglement by well-known dolphins, most were based on scars, but 12 dolphins were observed with gear, including 8 in fishing line, 3 in crab trap float lines, 1 in a bathing suit. 2 of the dolphins died from entanglement. 1 died as a probable complication of entanglement. 7 might have died without intervention. 2 shed the gear on their own and survived. Most injuries involved constricting lines cutting through appendages, a process that occurred over periods of weeks to months, and it's probably horrible. Injuries to the distal portions of the flukes of the dorsal fins may not be fatal, at least. All 10 of the adult females that were observed with entanglement wounds or scars subsequently produced calves. So from this kind of information, we can observe that the absence of cases of stranded and tangled dolphins from the cases considered for this report seems somewhat surprising given the proportion of cases of rescue captures for disentanglement, 10%, and the frequency of occurrence of entanglement cases in free-ranging animals. This finding suggests that entangled dolphins are more likely to die than to strand, or are unlikely to become successful rehabilitation cases, and therefore this underscores the value of early intervention through field disentanglements. Looking at the table at the bottom of this, we can see that stranded, rehabilitated, and released bottlenose dolphins 31% of the cases were successful. For those that were rescued, rehabilitated, and released, 43%. And by far the largest category of successes was those that involved rescued and released animals that were treated immediately and released. We've been able to do a population viability analysis looking at the potential value or looking at the value of interventions. And what we have found is that interventions definitely make a population level difference. We can leverage population level benefits by rescuing individual dolphins. The picture on the left puts a point on all of this. There are 4 mother-calf pairs in this photograph. 3 of the mothers benefited from interventions, and without those interventions, they and their calves probably wouldn't be in this picture. And then subsequent to this photograph, 2 of the calves in the picture have also had to be rescued. It's a fact of life for these animals living in the inshore waters where there's a lot of people engaging in a lot of activities and a lot of fishing. Interventions are necessary. So in most cases, small cetaceans and their populations would benefit from disentanglement efforts if they can be accomplished safely. So we have several options. One is the remote disentanglement of free swimming animals. The risk to the animals is low. The risk to the rescuers is low. The requirements for this is that you've got to be able to get your cutting tool, your hook, or your grapple safely around the line. The line can't be too tight around the body or you'll never get it between the animal and the line. And you must be able to approach the animal sufficiently closely to be able to use the tool. This is the best option if it's possible. So the main tools that we use for this disentanglement of free swimming dolphins are long-handled cutting tools like you see on the left on sturdy poles. And there's a blow up on the right-hand side. In the case on the left, it's a boat hook that has a blade that's secured inside so that it has the option of grabbing the line or cutting the line. And then there's a specially designed tool for whale disentanglements on the right-hand side with the red handle. We also have developed a grapple that can be attached to a pole and to a line so that you can get it around the entanglement. And then if it pulls free from the pole, you've got it on a 3/8-inch line that allows you to retrieve the animal and be able to work with it. Note that on this grapple, the points are padded with tape. Our first remote disentanglement was in June of 1996. There was a dolphin that was trailing 484 meters of 80-pound test floating Cordacron squidding line in a number of balls trailing behind it, acting as a sea anchor. We were able to use a boat hook to get a hold of this 7-year-old female dolphin by pulling on the line, pulling it up next to the boat and cutting the line away by hand. We got the vast majority of the line. There were a couple of strands trailing behind. And for the next few minutes, that dolphin rode at the bow of our boat looking up at us as we reached over with the boat hook to try to get a hold of the line, a behavior that we'd never seen before. Usually they would shy away from anything that you would put in the water near them, but there was something going on here. But this animal was caught a year later, and we were able to examine it during a health assessment, and we find that there are scars from it, but the fluke had healed nicely. We were able to remove monofilament fishing line that was tangled around the dorsal fin of one of our older males, and this was done remotely with a cutting tool, and the line was mostly removed so that the rest of it came off on its own, and by February of 2009, this animal was free of gear and remained that way for years. Not all cases are successful. In this case, an entangled yearling calf, C797, was seen with gear on it. We tried to organize a catch and release rescue, but the animal and its mother never went into shallow enough water where we could do that. We finally were able to approach it with a long-handled cutting tool and boat hook. We grabbed a hold of the line, pulled the animal up to the boat. We were able to clear all the gear from the animal and release it. It swam back to its mother, but 5 days later, the mother was seen and the calf was nowhere to be found. So we consider that one to be unsuccessful. In some cases, you can be partially successful, and even this provides relief for the animal and provides it with some degrees of freedom for healing. In this case, we were able to remove part of the disentanglement from CMA 1917 with a long-handled hook. Last year, we had a team led by Aaron that went up to Cedar Keys, north of Sarasota, to try to get some fishing gear, in this case, it's aquaculture mesh, off of a calf. This was restricting the animal, it was cutting into the animal, and there was concerns about whether or not this was life-threatening. So with a long-handled grapple, Aaron and our team went out with the University of Florida's rescue team and the Cedar Key Research Group, and they were able to find the animal, approach it, and use the long-handled tool to be able to grapple the line off. So see this video here. The mother and the calf are approaching the boat. Aaron's on the bow with the tool. He reaches over, he swipes at the animal. At first, he wasn't sure he got anything, but the next surfacing showed the animal was missing the mesh. It had cut through it and pulled it off. And on the right-hand side, you can see photographs of the dolphin a year later, looking just fine, having filled out and survived quite nicely. A second option is rescue, treatment, and immediate release on site. The risk to the animal varies with a variety of conditions, including the age, whether it's a dependent calf, a geriatric, or an independent juvenile or an adult, the condition of the individual, its level of experience with catch and release process. In Sarasota, we're fortunate that many of the animals have been through the health assessment at least once. It varies in terms of risk to the rescuers, and these vary with conditions in the habitat. Water depth is an important consideration. Your rescue team needs to be able to breathe in order to help the dolphin to breathe. So water less than 6 feet deep, preferably less than 5 feet deep, is ideal. The substrate is important. You want to have a hard bottom if possible. Currents will catch a net, even though it doesn't look like a solid structure. Currents will dangerously catch a net and create a bad situation. You want to have the right kind of temperature to work in if possible to be able to avoid hypo or hyperthermia. And you need to be concerned about biota, including sharks, stingrays, and other creatures like jellyfish. And then, of course, the animal size and condition makes a difference here because a thrashing 600-pound male bottlenose dolphin can do some damage. The requirements are that the animal must be in catchable waters. You need to have an experienced rescue team. You need to have well-tested equipment and protocols. This is a better option than bringing the animal into rehab as long as the injuries or condition do not require more than immediate one-time treatment. The opportunity to mark and tag the animal for follow-up monitoring to evaluate the success of the approach of the treatment is very valuable, and it also allows you to assess the need for further intervention down the road. So the tools of the trade. You need an experienced dolphin catcher, an experienced team and veterinarian, the right kind of net, ideally not too deep. You want it to be light enough for the animal to lift to the surface. And a floating mat can be helpful if the water is just a marginal depth, where you can get the animal and your team up on the mat and be able to work with them. For follow-up monitoring, there are several tools that are available. Rototag is a simple thing, cattle ear tag that can be punched through the fin, especially if you create a hole to start out, and provides the ability to distinguish that dolphin from other dolphins in the area. Freeze brands with numbers supercooled in liquid nitrogen and applied to the skin provide unambiguous identification for many years to come. For tracking purposes, the ability to use electronic tags has evolved greatly over the decades, from the very large CB range transmitters that were used in the mid-1970s to VHF radio transmitters that can still be useful for going out and doing direct tracking of the animal if you know where to go to look for it. But we prefer satellite link transmitters, and these have evolved from large packages that cover much of the fin to small tags that are pinned through the trailing edge of the dorsal fin and operate off a single AA battery. These wildlife computer tags that we use, the spot tags for location only, and the splash tags for dive depth and duration and location, are very helpful for allowing tracking, and in the case of the spot, for getting you to where an animal might be, so you can do visual observations as well. The splash tag provides behavioral data that can provide you with some indication of how well the animal is adapting to life post-release if you're not able to get out and look at it directly. We run into situations where the animals just can't be caught. The situation isn't safe, the animal's not shallow enough, and in this case, we're trying to develop a darting situation where the animal can be sedated. It's still in development, but progress is being made. Just within the last month, the Cetacean Sedation Delegation has been working with Dan Inject to refine and iteratively test the DART delivery systems. And we have another set of veterinarians working to determine what the most appropriate drugs and dosages might be. So we've tested the delivery system on carcasses being towed behind a boat. There's still some refinements that need to be made before this is ready for prime time. Here's an example of a case where we had a dolphin that was trailing, a small dolphin that was trailing a large amount of fishing gear that was also further sea anchored by biogrowth, and it was life-threatening. It was cutting through the fluke. Our team went out and was able to remove some of the line using a long-handled tool, but not all of the line, which then meant that we had to get permission from National Marine Fisheries Service to go out and perform a catch and release rescue a few weeks later.
Recently, the Chicago Zoological Society's Sarasota Dolphin Research Program, also known as SDRP, led an effort to rescue a 2-year-old dolphin calf whose tail fluke was entangled in fishing gear. Staff observed that the calf was having trouble using her tail fluke and was instead using her mother's slipstream to swim. On February 21st, the SDRP, in collaboration with several partner organizations, conducted a catch and release effort. 51 individuals, including veterinarians, biologists, stranding responders, trained handlers, and law enforcement officers, came together in Sarasota Bay. They dropped netting around the calf and mom in shallow water and were able to safely secure both animals. The team removed the fishing line and debris from the calf and administered an antibiotic to help prevent infection. They also gave both animals a thorough examination and took blood samples, heart rates, and respiration rates. The mother was fitted with a satellite-linked tag so that biologists can continue monitoring the calf, whose tail fluke received considerable damage from the line. The expert team worked quickly, and the dolphins were released in less than an hour. The SDRP has conducted dozens of rescues on dolphins who have suffered entanglements. Other dolphin injuries and deaths from human-related causes include boat and propeller strikes, illegal feeding of wild dolphins, and environmental contaminants. You can help protect wild dolphins. While enjoying our waterways, be aware of how your actions can impact marine life. Dr. Randy Wells, director of the SDRP, shared the following tips. Don't feed wild dolphins, stay at least 50 yards away from marine animals, reel in your fishing line if dolphins are nearby, discard fishing gear and trash properly, and use corrodable fishing hooks. Although the removal of the fishing lines was successful, the calf is not yet out of the woods. Biologists will monitor the calf as it heals and are hopeful that it will adapt to and overcome its significant injuries.
This video is a little bit dated at this point. We have seen the calf numerous times post-release. It has regained the use of its flukes and it's doing just fine. A few other cases that we've had of rescue and release. This is a dolphin named Placida who had fishing line caught in boat strike scars on her fluke. We were able to catch her, remove the line, give her an antibiotic, and release her on site, and she was seen on multiple occasions post-release. Working with a very collaborative team, an experienced team up at Johns Pass, north of Sarasota, we were able to help with the rescue and release of a dolphin named Vidalia, who had fishing line cutting in to its mouth and to its dorsal fin, and it was seen multiple times post-release. This 9-month-old calf named Nellie was seen with a line that we don't really know what the origin was, wrapped around it and embedding in the tissue of the calf as the calf was growing. It had a metal hook, but not a fish hook, that was attached to it as well. We caught it and its mom, removed the gear, and released them on site, and we frequently see Nellie, to the point now where she's produced 3 calves of her own that we're monitoring in the Sarasota area. As kind of a novel entanglement threat, we had a dolphin that swam into a Speedo bathing suit in 2006. Scrappy had that name before he swam into the suit. It was actually more than just a humorous anecdote, though, because the very soft tissue of the bathing suit was still enough to cut into the anterior insertions of the flippers, and the cuts were getting close to major blood vessels that would have led to the animal bleeding out. But we have removed the fishing gear from, or the bathing suit from Scrappy. He's out there swimming in the nude and doing just fine. The third option is rescue, rehabilitation, and release. The risk to the animal varies with the age, again, whether it's dependent calf or an older individual. Its condition, but if rehab is recommended, then by definition, the animal is at higher risk. The experience that it has with catch and release process, the duration and the nature of transport to and from the rehab facility, the longer the transport, the less the probability of success. Its exposure to humans. By being exposed to humans in a rehab setting, it may interact with humans upon return to the wild. The risk to the rescuers vary in the same way as I described before. The same factors enter in for catch and release work. The requirements are that the animal must be in catchable waters. We have to have the experienced rescue team with a veterinarian. We need well-tested equipment and protocols. There needs to be a suitable rehab facility nearby, and the transport options must be available. This is the least desirable option, but it may be necessary if an animal is unable to fend for itself or it requires repeated or extended treatment. And again, the opportunity to mark and tag the animal for follow-up monitoring to evaluate the success of the approach and treatment is an important thing to take advantage of. The main tool of the trade here is a rehab facility. These are photographs of a facility that we built at Mote Marine Laboratory that was used for a number of years before Mote decommissioned it a couple of years ago. But it had critical components such as a critical care pool, crane, a rehabilitation lagoon, veterinary offices nearby, and that sort of thing. So our first case was a dolphin named Matt, who became entangled in a crab trap line. And he was brought to Mote Marine Laboratory. He was treated and then returned and released, and he did just fine. He was seen multiple times post-release. In 2007, we rescued a very young dolphin named Philly. It was the young calf of a well-known Sarasota area dolphin. Philly had deep entanglements wrapped around her tailstock and going down to the bone. She needed to come into Mote Marine Laboratory for surgery. At the time that we caught her, she was recently separated from her mother at an age that was much earlier than what we usually see from mothers and calves. So we brought her in, we did rehab work on her, we released her with a radio transmitter, VHF transmitter, and kept track of her for about a month, but then she went missing after that. She had been in a very limited area up until that time, and then she disappeared. Extended surveys did not find her anywhere. Her release was conditional because she was at such a young age. It's really unusual for mothers and calves to separate when the calf is only a year old, especially when the mom is still around. Though in addition to the boat strike and the entanglement, she had boat strike wounds that had the entanglement caught in it. In addition to that, she suffered from high-frequency hearing loss. She continued to swim through more fishing line after release, as evidenced by small pieces that were attached to the tag. And her disappearance after consistent limited ranging patterns suggests that she didn't survive, even though we did expanded surveys to try to find her. Experimental releases with monitoring improve our ability to select cases for rehab with the highest probability of success. Another case that was more successful was Toro, a dolphin that was seen with an entanglement around or through its dorsal fin and then around its flipper, leading to highly necrotic tissue on the flipper. Toro was caught down in Charlotte Harbor area, brought to Mote's Dolphin Hospital. The line was removed, she was treated and released, and she was seen on numerous occasions post-release. So this leads us to our decision trees. How do we make the decisions for what we're going to be doing? First of all, in the United States, anything we do in terms of a rescue is governed by the National Marine Fisheries Service, an agency under NOAA. And so we must consult with them if there is an entangled dolphin. If it's a non-life threatening situation, then we have several pathways open to us. If the dolphin is approachable, we can attempt removal. If it's not approachable, and it's a high-risk animal that's young or old or compromised, then we don't intervene, we just monitor. If it's a low-risk animal and the conditions are safe, then we may attempt to capture, treat, tag, release, and monitor the animal. But if it's a low-risk animal and the conditions are unsafe, then we don't intervene, and instead we monitor. In life-threatening cases, once we get the go-ahead from National Marine Fisheries Service, we have two situations. The dolphin's approachable, in which case we attempt removal of the gear, or the animal's not approachable, So if the conditions are safe, we'll attempt to capture. And if there's no further care that's needed, we'll treat, tag, release on site, and monitor the dolphin. If we are able to capture the animal under safe conditions and it needs further treatment, then we admit the animal to rehab where it's treated, and then upon release, it's tagged and monitoring occurs. If the animal isn't approachable and the conditions are unsafe, we don't attempt to capture, but we monitor it and we prepare for a stranding response. There's lots of variance on this, depending on the situations and the resources available, but this is the basic framework under which we operate. And so in conclusion, in most cases, small cetaceans would benefit from disentanglement efforts if they can be accomplished safely, leveraging population conservation benefits. Once an entanglement case is detected, the sooner an intervention can be done, the better the chances of a successful outcome. As a general rule, the simplest and least interactive approach possible to remove the entanglement should be used, depending on the nature of the entanglement and the condition of the animal. Bringing an animal into rehab should be considered only if absolutely necessary. The risk to the animal and to the rescuers must be weighed in making a decision on the best approach for intervention. And finally, we always recommend follow-up monitoring if there's any way to do it. I'm sorry that I can't be there to actually answer questions in person, but if you do have questions, talk to Krista or send them to me via email, and I will try to get back to you with a response. So with that, I wish you the very best for your workshop, and I hope that all goes well, and have a great day.